like 1:30. Is that all right?
Yeah, sure. All right. So, and we're off. Welcome to another episode of Day One Digital. It's our first episode for our technology category. And I'm absolutely delighted to be joined by Josh Robinson here, who's a machine learning researcher at MIT.
Hello, how are you doing, Charlie?
Yeah, I'm very well, thank you. Cheers for coming on. It's amazing to have you back in the country and also
No
be able to
problem, mate.
chat to you on here. So I guess, yeah, we always kick things off in the same way. So tell us about yourself, Josh, introduce yourself, and then tell us, what was your day one digital?
So I am a PhD student at MIT at the moment, but I'm from the UK and currently in the UK due to COVID. But yeah, I am currently in the computer science and AI lab at MIT doing some ML research, but I guess we'll get onto that in a bit. My day one digital, I don't know, I think it's probably the same for a lot of people, which is there isn't really a specific day. It was sort of a gradual emergence, which is that I did an undergraduate degree in maths, and I was kind of essentially, like, to put it like simplistically, I was filching around for a purpose for all of this because I really enjoyed my undergraduate degree in an intellectual level, but I started to wonder, like, what next? Like, where do I take this? And somehow, I'm not really sure. I started to read about machine learning things and then decided to take it in that direction. And so in that sense, I think that was the moment that I sort of became aware of this area and became interested. It was just very gradual.
And when was the first sort of point that your maths went from being, I guess, abstract theoretical mathematics to actually being stuff that can be used to run on computers or underpin computer systems?
Well, again, it's sort of like it went in stages, like for different research projects. So, the first research project I did, there was a bit of coding that I did, but I didn't really believe that it was working very well. And then like the next project, it sort of worked a little bit better, but it still wasn't great. And then maybe on the third project, I finally started to have this sort of interplay between like some theory that I've been studying and actually like experimental observation. And so I say on that project, it was on something called weakly supervised learning, that I actually started to feel like I was able to observe in practice some of the things that I was studying and working on.
Cool. I still remember, I mean, for anyone who doesn't know, me and Josh have been friends since we were quite young. So I actually still remember the day you came to me and said you weren't going to study economics at university, but you wanted to study maths. And I think you said that, while you loved economics, maths was the kind of purer, deeper form of knowledge. I'm wondering, how you feel about that decision now. Do you wake up in the morning and wish you were an economist?
No, I don't think so. I have utmost respect for economists, but I'm a bit afraid of their job is too difficult. I'm afraid. I forget who it was that said it, but economics is the hardest science, I think.
Cool.
Yeah,
So
no.
moving on, I think I'll give a quick overview of the sort of brief talking points we outlined. Perhaps more as guidance than rigid talking points. But having introduced yourself, I wanted to ask you about what it's like out in America at MIT and how you feel like those institutions differ from the UK. And I wanted to really drill down into your actual work and your research, so people listening can get an understanding of what kind of mad stuff you guys are up to out there, and what you're working on in particular. Then moving from your work, I wanted to hear your thoughts on general trends in machine learning, perhaps what your colleagues are working on, which areas really excite you, and which ones really are going to have the largest impacts in your mind, or really pushing the boundaries of what's possible in this field. Then I was hoping we could talk a little bit more about transfer learning, which is the area we're working on at Algomo, our multilingual AI powers our systems. Then a little bit about the adoption of technology, so how the research that you see going on around you filters into people's day-to-day lives, into industry, into applications.
Yep, sounds like a great agenda.
Well, there's two more. Finally, then professional sort of standards and regulations, which is a bit of a hot topic, but I really wanted to get onto because I was at a conference, digital conference 2 days ago with a philosophy group I'm in, with some guys who do sort of AI regulation stuff. So it's a topic I'd really like to pick your brain about. And then finally, to conclude it, I thought there's nothing better to for an end note than a bit of advice you might have for any other students looking to move into this field and follow in your footsteps.
All right, great. Sounds like we got a lot to get on with.
Yeah, for sure. Okay, so, well, yeah, question 2, what's it like out in America? What's MIT like? And how do you feel like American institutions, or at least the one you're in, differ from British institutions?
Okay. Yeah, I mean, interesting times in the US for sure. I don't know. I think the first thing I should say is that, of course, America is a continent-sized country, and so I can only really speak from my lived experience. So it's difficult for me to necessarily be able to draw broad conclusions about the US, but I can tell you about MIT and the Cambridge bubble, and it definitely is a bubble. This is kind of a good thing and a bad thing. I guess the bad thing is that it means you have to have sort of a limited exposure to American culture and life. But I also think that's kind of inevitable. So maybe it's not such an indictment. But on the good side, the cool thing about like Cambridge, which is the city that MIT is in, is that it's really like I guess like a kind of paradise for scientists, because there's a bunch of other like great universities around and lots of biotech research labs and so forth. And so like if you go into a coffee shop or something around, then you're likely to overhear just kind of random conversations of scientists talking to one another and pitching ideas and debating them, which I think is a great environment to try to be a productive researcher in.
That sounds fantastic. It's a real sort of forum of ideas.
Yeah.
Nailing down it a little bit then, I always felt like American universities, or certainly research institutions like MIT, had a lot more of a commercial focus than British institutions.
I suppose so. I mean, they're typically privately run institutions. They often have to fund themselves, and I think in some of them they obviously do have a lot of like endowments and like raise a lot of money from well wealthy people like a lot of the time. But I guess for me, like that's maybe, I mean, that's an important difference. But maybe something that comes to mind to me quicker or earlier than that actually is that at least at MIT, I feel like there's a much greater focus on research than on teaching. I think that's probably specific to the institute. So you know, at MIT, there's more graduate students than there are undergraduates, and kind of everyone is really encouraged to undertake research, including the undergrads. So I think about 95% of all undergrads partake in some kind of scientific research during their undergrad. There's a scheme called the Europe Undergraduate Research Opportunity Program, where they kind of get paired with a lab and a professor, and they do some work in there, which is a great way to get people into the field, you know, get people doing research as soon as possible.
Yeah, sounds like there's a lot of research going on, obviously. So why don't you tell us about your research and what you've been working on?
Sure. I mean, in the very broadest terms, these days I work on something called like unsupervised representation learning, which I think is a really interesting topic. And not to get into too much detail straight away, but the idea is to try to essentially extract useful information from some data that you have without necessarily having supervision to guide you, so like labeled data. So it would be essentially just raw images or raw text. And this is, you know, this is actually a very nascent field. That there's a lot of people working in this kind of area, but thus far successful machine learning systems typically work using huge data sets of labeled data. And that's awesome that we can show that that works, but it doesn't really scale to general problems because you actually have to put labeled data. So yeah, I think this is a very interesting area, and so I mostly work on that.
I was going to perhaps try to explain in layman's terms the difference between labeled and unlabeled, because the way I've always understood it, I mean, coming from my background in philosophy, I guess I try to project as much of the you know, theories that I was acquainted with as an undergrad into your work, perhaps a little bit too much, because you often come back and go, you know, cute analogy, but really isn't how it is.
I always remember the one time when I was describing something I'm doing and you said something like, that you're working within a Platonic framework. You need to be more like, I don't know, postmodern or something. And I'm like, how how is that possible?
But it has been nice subsequently that you've come back, certainly in this break, and had a really renewed interest in philosophy. We've had some great discussions. I've always been a little bit really like conflicted because I'm so happy to see you reading philosophy and understanding it, I would say, to a really strong level, like to an undergraduate level, I would say. And at the same time, really frustrated that I have no idea what you're doing, but you can pick up a book and understand stuff that I spent, 3-4 years studying.
I'm sure I don't understand it anything like you, mate. I really wouldn't over-egg myself on that.
I don't know about that. Okay, let me give my vague sort of analogy to labeled and unlabeled. Well,
go on.
so if you use the example of linguistic categories for animals, you could basically get 100,000 photos of cats and 100,000 photos of dogs, or let's say lions and tigers, and you could start showing it photos of lions, and it would say lion, and you'd say yes or no, and vice versa, and it would learn from that process. But then obviously if you showed it a liger, it'd be like, what the fuck is this? It wouldn't be able to do anything. Whereas my understanding is you would then, in an unlabeled sense, show it all kinds of different photographs and probably looking at them at form categories. And the idea would then, when it saw a liger, it could potentially make a new category to deal with that new piece of information.
Yeah, more or less.
Yes.
Yeah, I mean, yeah, congrats. Yeah, exactly. Like labels kind of like constrain, in a very philosophical sense, the kind of type of understanding you have, because you have to bin stuff into different categories. It doesn't allow for such nuances, perhaps.
But I imagine you're not sitting there looking at photos of cats, at least not at work.
I mean, you say that, but it does happen sometimes. I mean, a lot of the machine learning data sets that people use have lots of animals in, and part of like running experiments and making sure stuff works is to actually take a physical look at the data and visualize it. So you do look at the images that are in these data sets, and so there are cats and dogs.
I always liked on your website that when it has your papers you published, you actually put photos of your cats, which I thought
yeah yeah, because the kind of convention, the typical thing people do is to have like the title of their paper and then like a representative diagram from the paper next to it. But I guess I just thought, like, I'm gonna just do something a bit different. I don't see why not.
Which paper was Merlin? Because obviously no one would know, but Josh has a cat called Merlin, who is a very special creature. I remember like he'd often try and run away, but run away into this tiny closet bathroom of which there was no escape, which I always thought was a strange strategy to basically corner himself.
Yeah, yeah, not the smartest cat, but very adorable.
What paper is he?
So that was my first paper from MIT. It was at NeurIPS 2019 on a class of probability. This is actually from my previous line of work, which was more on probability theory and like modeling diversity and negative dependence. And so this was studying a class of distributions that could be used to model these things and to develop very basic algorithms for doing learning and inference with them. Yeah.
So that was your master's degree research at Warwick. Is that?
No, that was something I did at MIT when I got here. There was a different paper from Warwick.
Okay, yeah, but were you saying the two sort of led on to each other?
They were both. They were related to one another in the sense that there was definitely a very strong probabilistic or probability theory slant to them, like less machine learning and more probability in those ones.
Okay, well that sort of gets on to the question I think I'll actually save for the end about which fields lead best into ML, but I'll say that to the end. But I guess before we move on, can you quickly run through the rest of your research, particularly what you're working on at the moment?
Yeah, so I think the thing that I'm really interested in these days is something called contrastive learning, or actually a slightly broader topic is something called self-supervised learning, where again, all of these things are, once again, a subtopic of unsupervised learning, so when you don't have labels. But the idea of contrastive learning is really to take like pairs of inputs and to really just contrast them and say, like, so have a notion of similarity between inputs and a notion of dissimilarity, and essentially learn to discriminate them and say, like, okay, these two, you put them nearby into some sort of like theoretical space. And if they get embedded nearby to one another, that should hopefully mean that they have some kind of like semantic similarity to one another. And if they're far apart in the space, then they're not related. And this has been one of those topics, contrastive learning, that really, it blew up in 2020. It was a really landmark year in this area, and it's basically been empirically verified to work extremely well and is state of the art in various different problems. And yeah, I find this fascinating, and so I've been working on that a lot recently.
Wow, it sounds like a challenging field. Is that still unlabeled data? So you're doing contrastive learning with unlabeled data?
Yeah, exactly. There are some contrastive learning papers that use supervision, like use labeled data, but the vast majority of it is unlabeled. Yeah.
Okay, cool. Well, I won't lie, don't understand everything, but hopefully some of the audience have a deeper understanding of your research areas, or this drives them to get on Google, or I don't know, some kind of price more detailed repository. Is it?
Go on Archive, it's all out there.
Go on Archive. So is that the database you'd recommend for looking at research?
Well, I mean, that's the database where it's all stored. I wouldn't necessarily say that's the right way to find the research that you're interested in. You should probably use Google for that, or Google Scholar.
And if you were on Google Scholar and you wanted to pin down the top 5 areas of ML research that are, leading the charge at the moment, what would you Google? This is a very bad segue into the next question, which is, what are the general trends?
Right. Yeah, I mean, so the first one, I'll just go out and say it straight away, is this unsupervised representation learning. So exactly the topic that I do my work on these days, but it's really like resurging. This is an idea that's kind of old from like previous iterations of thinking in AI, but has really come into its own in the last couple of years. So one of the key examples that many people will have heard of in this area is BERT. So that's in the area of natural language, but there's also been similarly landmark achievements in the areas of computer vision and also graph representation learning and so forth. So I really think that this unsupervised representation learning is a really big thing that's happening now, and is through things like BERT is actually filtering through very quickly into practice as well as just research. I think another important topic, so that I don't bang on about the same topic the whole time, but it again is quite related actually, is transformers. So that's like a somewhat new, I think, 3 years now since they were proposed, neural network architecture, which is actually exactly the architecture that's used for BERT. Of course, BERT uses a specific way to train this model, but the architecture itself is being deployed for all sorts of different applications and purposes, and is really starting to become quite dominant in many areas. In the same way, like you may be familiar with like convolutional neural networks. They're sort of like specialized for like image understanding. Transformers are this kind of like very general purpose like architecture that is just doing a lot of interesting things in a lot of areas. And then the final thing I would say that I think is interesting is this thing called graph representation learning. So a lot of previous work in machine learning has been on, I guess, like images and natural language. That's kind of like the structure of the data that comes. But an even more general like data structure is a graph. So like a network, basically. Like think of like a social network with like nodes and like connections between them. And in the last couple of years, there's been a huge explosion of like research in that area, and it's starting to work really well to like do learning on this kind of data. I think I saw a tweet saying that at the last big machine learning conference, 20% of all the papers at that conference were on graph representation learning. This was the ICLR, submissions to ICLR 2021. Cool. So it's a big topic, growing.
Wow, there is a lot going on. And would you say the field is growing at a significant rate? Like the volume of research is going in, and the volume of new sort of areas that are cropping up?
Yeah, definitely. I mean, one way you can see this on the research side is in terms of how big the conferences are getting. So each year there's a few major machine learning conferences, but each year the number of papers submitted to them and the number of people that want to attend the conferences grows by about 20%, maybe 25%. And that's been going on for the last like 8 or so years. And so that's obviously compounding pretty quickly. And so, yeah, I guess it is growing. Yeah. for sure.
That must be exciting and at the same time, a little bit challenging. Do you feel like it
Yeah,
gets harder each year?
yeah, well, I mean, the field just gets bigger, so I wouldn't necessarily say that people get crowded out. So there's more papers submitted, but there's also more papers accepted. So the actual acceptance rate stays about constant for papers there. But I guess one possible negative of this is that the conferences start to become really, really big. So I think the biggest one is NeurIPS. And to be honest, I don't know how many people, like there may be like 13,000 or something attendees at the last NeurIPS. Which is significantly up from the 2,000 or 3,000 or something that there would have been in 2010 or thereabouts. And so that just makes it really hard. That just makes it really hard to meet people that you want to talk to, basically, like other scientists, because there's just too many people around. I see your dad popping in to say hi.
Interesting that he comes in after I had a long conversation with him about how I was about to record a podcast session with Josh and how important this was. But I'm sure he has some interesting contributions to it.
I'm sure it was very important. It was an emergency.
I don't know. He seemed to come in and chastise me for my room being messy, which I feel like is a real double-edged sword.
But beneath the camera level, there's actually a whole load of messes there.
It's just books and other scholarly,
of course,
things. No, it's not. It's covered in socks.
For legal reasons.
Okay, well, so I lost the flow there. So yeah, the conferences are these like the kind of benchmark for how researchers interact?
Yeah, I'd say so. I mean, like definitely traditionally, the conferences have been the places where researchers gather to like meet and talk about things. There's always this thing of, like the little side rooms in the conference venue, though, like people will go aside and have like meetings in them with like other people they haven't seen in a couple of years, talk about what's up in their research and so forth. They also have a lot of industry people coming to the conferences these days, so it's not just researchers. And I mean that's a good thing. It allows like more like people to mix and like perspectives, although from a very narrow research minded perspective, that also actually makes it harder in a sense, because if you bump into someone at the coffee shop, then there's no guarantees that you can strike up a research conversation, because there may be someone that's sort of trying to think about it on the very like applied side of like just trying to be aware of what's happening rather than as a researcher themselves.
Okay, cool. So I guess segueing on, the next topic I want to talk about was to nail down onto transfer learning as a specific area. So I know it was released, or the research was led by researchers from Google, and they sort of open sourced it in a way, didn't they? Is that a fair assessment?
Which research are you talking about?
The bidirectional sentence encoders, so the BERT paper that was published.
Okay. Yeah. I mean, that's kind of the nature of the field. Like this open source research I'm a big fan of it. I think it's great. But yeah, I mean, like this stuff is really important, and it's all kind of connected, right? Because like actually this is what I was calling unsupervised representation learning earlier. That's what I would categorize BERT within. But you can also think about it as transfer learning. So I guess these days people would more talk less in terms of transfer learning, but more in terms of like just asking the question, how do you extract lots of useful information or useful knowledge from some source task or some data that you have? So for example, BERT is trained on I think it's on like Wikipedia and like various articles from the internet. So how do you extract useful knowledge from that and represent it in a useful way? And obviously that's related to transfer learning, where you want to basically you want to firstly learn some knowledge and then transfer it into new tasks, right, that you may want to perform. But I think people these days more focus on actually that first step of like trying to extract lots of general useful knowledge from some data that you have. And the transferring act is like maybe downplayed somewhat, because it's in some sense the first part that's the key to making it work.
Yeah, I've got you. So to anyone who doesn't know, we're working on transfer learning, or BERT's framework at Algomo. So our CEO, Hadis, was working for Barclays, developing their multilingual automation systems, primarily for like chatbots for customer service. And I think around that time, BERT was released, and I as I understand, he had this wow moment where he was like, sort of blown away by the potential applications of these language models to industries and to change and reshape how consumers interact with companies. What really excites me working for this company is this idea of BERT as a kind of democratizing force. Not only do they open source and release the research to allow other people to kind of build on top of it, but there's, in my mind, something inherently democratizing about that technology. So existing solutions in the chatbot market are either clunky sort of question and answer bots that just aren't really very effective, which I'm sure pretty much everyone listening would have experienced. Or they are used by very large corporates who spend significant amounts of time, money, and resources developing them, and therefore largely focus on heavy, large linguistic segments, which basically means that smaller linguistic groups and smaller companies, SMEs, are sort of left out of the party. But what we found with BERT is there is a capability to onboard smaller SMEs with their own knowledge spaces, and then apply that knowledge space to the pre-trained language models very, very, very quickly with not necessarily that large an amount of data, and then have this ability for them to understand their customers in, I think, 108 languages and match with the relevant response, which means a small company making, let's say, some kind of manufacturing good, consumer good, healthcare product, whatever it is, they might only have a few thousand customers who speak, I've got to pick a language now, like Romanian or any language, a smaller language, but those customers would nonetheless get support in their preferred language, which for me is, incredible to be part of that.
Yeah, it's really cool, and it's really nice to see the kind of like interplay and the benefit that both comes from like the researchers that sort of do the very heavy pre-training of these models, and then they very quickly get deployed and used by various companies. It's great to see that such a fast turnover from research through to application.
This does pin us down quite well onto the next question, which I put in the notes as technological adoption. And I guess what I wanted to talk about was the mechanisms by which this research ends up being applied and benefiting people in the real world. In my notes, I kind of outlined, I think, 3 different ways off the top of my head I could think about, which were large corporates, government organizations, and then startups, smaller organizations. So I feel like BERT really kind of outlines this quite well, because you have researchers probably working at academic institutions who then moved on into kind of Google-led research positions. And if you could elaborate on that relationship a little more, that'd be great. But then they've open sourced and released the research, and now startups are able to take that and build upon it in smaller teams, focusing on niche applications of it. Is that a typical way in which you see this research being realized in the real world?
More or less. I mean, it's difficult to pin one consistent narrative to how this kind of knowledge filters out. But yeah, it's definitely fair to say that one way that this kind of thing works is actually maybe through the research labs at technology companies would be the kind of core intermediary here, which is exactly where the research for BERT came out, right? And so that was from some Google research people. And so what they do, they're basically, for all intents and purposes, professors, academics. They write research papers on these areas. They're the same as anyone at an academic institution, and much of the important research comes from these labs. But the difference with them is that they're obviously connected to their respective organizations, their companies. And so I guess what the role that they perform is that the company can kind of be aware of, they stay via this process of having a world-leading research lab, they stay abreast of very contemporary themes in research. And then they're ready to sort of pluck out bits that they think could actually be useful for various products. And so BERT is a great example of that, where yes, it was a Google research thing that first developed it, but then they realized that this thing was really quite something. And so it actually got built into the Google search product very quickly. It was one of the first places where BERT was deployed in some product. But then at the same time as that, so that's kind of where the technology company gets its benefit from. That's, I guess, why they have these labs and spend so much time doing research. but at the same time, because there's a good open source culture in the field, and I mean, I would hypothesize that maybe the technology companies feel like in order to attract the right researchers, they kind of have to allow them to publish their work openly to people. And so because of that, that means that the work is available to outsiders, or people that don't work at these corporate research labs. And so that's where the startups come in, and they can start to deploy this kind of stuff in their contexts. But then at the same time, like, there could be other ways, right? There's always, like, you know, a story of some plucky startup that just does its own thing, and it really like has its own kind of like novel research ideas that it just implements itself like fully from scratch. So that's it's not a single process by which these things filter.
And at these research institutions, like, how is this kind of being maintained, I guess, is the question I have, because you've got essentially trillions in intellectual property. And it seems like, it seems like quite a delicate setup, right? Do you think it can last? Do you see it changing?
That's a great question. I honestly don't know, to be honest, if it can last. It might, it also might not. I guess, yeah, while the times are good, I think it will definitely last. But you know, like, things could change sometime in the future if, things get more challenging. I know there was a story of a Microsoft research lab on the West Coast that got just completely shut down. And so I guess that's kind of like could be a foretaste of what could one day happen to these research labs if the companies think that they don't make business sense. And I guess at the end of the day, like, these corporate research labs, they do have to make some kind of business sense, however indirect it is. Otherwise, they would just shut them down. But yeah, I mean, for now, like, for all I can tell, these big tech companies are benefiting a lot from these labs, and it's all good.
Okay.
In terms of the labs being around.
Okay, kind of leading on for this question, then, I wanted to ask you about regulation, about ethics, about how you see the need for increased oversight in technology and in the work that's done by researchers. To provide a bit more context, sorry to interrupt. A couple of days ago, there was a conference I was attending, this Let's Fight conference. So the guys there were from the For Humanity Institute who were speaking, and they were trying to develop AI auditing and compliance solutions to basically come in and they were saying help companies to do this, because they were presenting this idea that there is a desire to get increased oversight, because it's risk mitigation. He was saying, I think in some capacities, it's not like they're trying to hide what's going on. They would like to understand what ethical concerns there could be, because, you know, if those things are left unchecked, they can have serious negative impacts on the organizations.
Yeah, definitely. Yeah, I mean, this is something that is, you know, really important. In some sense, it's natural that we haven't figured it out yet, because like these problems are still quite new, and so like you don't, like, a new like big area doesn't just emerge with regulations already set up. It takes a bit of time for them to, like, essentially the problems to manifest and then the solution to present itself. But yeah, no, I think that this is something that really as many people as possible should be thinking about. I think my personal, I guess, take, or like some opinion I have on this, is that it definitely needs to be sort of regulation at a kind of institutional level, where essentially some kind of like auditing system for the processes by which new algorithms get deployed, to check that they have like various there's been various like good practices executed during the production, and in particular, maybe I don't think this can be the same as a kind of like professional standards type of thing like you have in medicine, where you kind of take like an individual oath of honor. I don't think that would really work. I think at least one reason why that wouldn't work is that it conflicts really heavily with the philosophy of open source work. Like, so much code is just freely available online on GitHub, and the whole point of that is that it means that anyone who wants to can get on there and start playing around with it and using it. And so there's kind of like no barriers to entry in that sense. And so I like, unlike medicine, where of course you can't just start practicing medicine on people. So I don't think that you could have a kind of individual oath, or I can't really foresee how it might be possible.
Yeah, okay. I mean, that's an interesting one. So I was chatting to my parents about this just before I came up. So my mum works in the medical field and my dad's a lawyer. So they both have, you know, jobs that require them to swear sort of oaths of don't be a dickishness. But also a lot of the work my dad does is about these kind of professional standards. So he's done cases in the past regarding dentists who had who committed crimes even in different countries, not violent crimes but financial crimes, and were thereby being struck off the dental registry because the professional body of, not chartered, but, you know, official dentists were saying, we don't want this person representing our field. They're clearly unethical. They're a bad reflection on us. So there was this idea of a kind of centralization of those fields. But I guess in a world of machine learning and, you know, data and computer science, which is more globalized than ever, I agree. It seems very difficult to create this idea of national professional standards bodies.
Yeah, it just seems a bit in conflict to the philosophy of open source work to me, to have like individual level responsibility for this. But as we were saying, I think that there's like a huge need and scope for at a kind of company level to have like processes that sort of check and carefully verify various like aspects of the algorithms that they choose to deploy. I think that that's totally doable and very like needed. Yeah.
I think that's what was exactly spot on. So what I sort of had concluded in response to your spanner in the works that is the open source culture question, right? Which is that you're going to have teenagers sitting there on their computers trying to code this stuff. You can't introduce a law saying thou shall not run this kind of function in Python until thou have sworn the oath. It just doesn't seem feasible.
Exactly. I just would never want to stop people doing that, because it's really the way that I just strongly believe in that philosophy, that this is one of the ways that the field stays dynamic. I just can't foresee it being a benefit to the field to somehow add barriers to entry like that.
I guess my answer to this then, my sort of solution was that people doing this work aren't going to have significant impact until it becomes embedded in large systems that influence people's lives, which thereby means it has to be essentially applied within a commercial setting, or at least a government organizational setting. So thereby it's up to those organizations to set codes of conduct and to set ethics statements and guidelines. But then I realized, in effect, they're already doing that. I'm sure Google has an employee ethics sort of code of conduct. I'm sure they have these guidelines through the wazoo. So I think the issue is there isn't a kind of centralization of these across the board. So I think what is needed is a large number of companies to come together and have a conversation about how they're codifying these rules and these guidelines.
Yeah, I think you need a kind of unified auditing system, like a standardized auditing system, like a process that every deployed algorithm should go through to just check that it has necessary properties. And I can't really foresee that unification coming from the private sector by itself. I think at some point, like parts of it would, I guess, by necessity have to be government mandated. So I think that there's a bit of onus on the government. They need to get up to speed with the state and technology and figure out how to audit this stuff.
It's an interesting one. It reminds me of the paradox of the philosopher kings from Plato's Republic. So Socrates was...
Wait, you studied philosophy at university?
But Socrates was sort of quoted as having said that we would only reach the sort of ideal society when philosophers become kings, or kings sort of adequately philosophize.
That's the philosopher.
So I guess in that question, is it going to be the philosophers who become machine learning engineers, or the machine learning engineers who adequately philosophize on matters?
Hang on. Who are the philosophers in this analogy? I'm lost. Is Mark Zuckerberg the philosopher?
Well, yeah. So I guess the philosophers are going to be civil society,
Mhm,
non-technical uh, entities that have an interest in
mhm,
social structure, ethics, law. And then
mhm,
the kings are going to be the ML engineers, obviously the people who have agency and dictate the course of events.
mm,
So the point I was making rather facetiously was that uh, what I see is the problem is there's a large barrier to entry for philosophy students or law students or people who act in this domain of sort of ethics, understanding and application to get a
mhm,
detailed enough understanding of the research that's going on the mechanisms and forces at play to introduce any kind of regulation.
mm. Yeah, that's interesting. Like, to what extent is like maybe a non-technical actor need, like, how much knowledge do they need to have of like the processes that they are um like managing and auditing in some sense? And I have to say, like, maybe there's a degree of like pessimistic outlook on that, which is that if you look at other kinds of auditing, um like auditing companies accounts and so forth, like the people that do that, they actually need to understand about the accounts, right, in order to do their job. And so maybe in the same sense, like they will at least have to be part of such an regulatory organization that has some technical understanding of what's going on. I mean, maybe there could be some more like progressive thinking solutions where part of this is kind of offlaid to the companies themselves. There's some sort of like box checking exercise that the government auditors have to do, but for lots of the technical parts, it's kind of has to be built into the cultures of the big companies. I'm not really sure, to be honest.
That is very interesting area. It's funny you brought up Deloitte because my mate Jack, who's just finished his PhD in philosophy at Durham and is now teaching in their law school somehow. He We just applied to a accelerator with Deloitte or backed by Deloitte, looking at potential solutions to start to automate or present machine assisted solutions to
Mm-hmm.
ethical compliance, basically thinking, can you develop frameworks, primarily like natural language understanding frameworks,
Mm-hmm.
to process huge data sets and then crop up potential ethics risks.
Yeah, I think that's a really interesting problem, and I think, of course, like with so many areas in automation, like it's never going to be the case of totally replacing human activity with machine activity, but more finding kind of a new hybrid, where like some of the heavy lifting, time intensive stuff is is shouldered by some sort of computer system that just saves people's time. So yeah, I mean, I guess on a philosophical level, I can imagine that this kind of thing could work, and the same thing could be said for like regulation of big tech. You could even automate parts of that, perhaps.
Cool. Well, before we get on to, I guess, the final question, which is advice you have, if there was
Mm-hmm.
going to be an oath for machine learning researchers and computer scientists, you know, what would you put in that oath, Josh?
Oh God, you really put me on the spot with that one. Oof. Thou shalt not conceal thy bugs.
Thou shalt
I
not
don't know.
conceal thy bugs. I thought, yeah, a good one would be, thou shalt document thy code as thou writes it, and not.
Yeah, yeah, that's just completely unrealistic. That's never going to happen.
I have had this before, like in my limited capacity as a front end web developer, where
Mhm,
I've taken over a project and there's just sheets of incredibly poorly written HTML and CSS, and there's just zero documentation.
mhm.
And the guy's nowhere to be seen. He's like in a different country, he's gone. And you're like,
Doesn't even
oh,
remember the project. Yeah, it is a nightmare. It is a nightmare, and it's a commonly occurring one. Like academic coders, well renowned for being spaghetti code that has no documentation.
well, see, I'm feeling threatened by what is probably, 2 pages of HTML, but I imagine in your domain, you can take over these like mammoth, epic, like 1,000 page sort of systems with no documentation.
That's a hopeless task. That's a thankless task. That would be horrific. I don't think it gets any easier, mate. Like the more technical you get, I don't think it makes it any easier to understand undocumented code.
Cool. So let's get on to the final question, which is any advice you might have to younger guys. So to frame that quickly,
Okay.
you came out of mathematics, undergrad and master's degree in mathematics. And if we sort of go right back to the start of this conversation, you mentioned that some of the work you were doing for as part of your master's degree research mapped fairly well onto what you then started to pursue in probability theory in the early days of your doctorate research.
Yeah, I mean, it segued quite well. I mean, the first thing I would say is that there's like, yes, there was the path I took, but that is not the only path at all. And in fact, almost the reverse, that it's maybe a more unusual path, like at least among like other math students in the UK that I know, not so many went that route per se. So I think in terms of just pure numbers, the most common route would be to study computer science in undergrad. But that's not to say it's unattainable for people from different fields. And I think if you really have the interest, then you can. But in terms of actually how to get going with this, like I'm not gonna, I don't think the way that I did it is necessarily like, or like the way I came to be in my PhD is necessarily the way I would do it if I knew what I did now. And I don't know, maybe the first thing I would do is just get on Twitter and follow a bunch of researchers and professors on there, because I feel like just by osmosis, you'll soak up a lot of like ideas of like current research themes, the dynamics of like the publication process and awareness of different conferences, and just like they often just, as people do on Twitter, just start like saying like their random thoughts, and it can be interesting to just sort of connect with what they're thinking in some way. But maybe on a more like actually useful, pragmatic way. I mean, that is useful, don't get me wrong, but like just going on Twitter is not going to get you like, I don't know, you're not going to embark upon a PhD just because you're active on Twitter. But I think a really important thing is to try to fight and really push to do research during your undergraduate, especially for like a machine learning PhD. Like many incoming students have already done research of some form or other before, and published papers before they start their PhD, which is, I don't know, I guess it's intimidating, I suppose. But I think it is important to do your best. I mean, you don't have to publish papers, that's not a necessity always, but to have basically some kind of evidence that you're capable of undertaking some research. I think that's a really key thing that you shouldn't forget in undergrad.
I think that's great advice. Firstly, I really like your point about Twitter, actually, because it does sound really simple, but I spent quite a lot of time curating the people I really closely followed on LinkedIn. And yeah, it frames me so much, because whenever I go on, I have these kind of American tech growth influencers just talking about the work they do. And then, yeah, that's not enough in of itself. But when I get a spare 20 minutes, 30 minutes, what pops into my head, it's something this guy said in this podcast. I go on, I start reading a blog post about it by HubSpot or something. And it just keeps me in check, because instead of going on Facebook or Instagram and just scrolling through rubbish, I go on LinkedIn, and when I'm distracted, I'm reading about other professionals and their work, which is directly relevant to what I'm doing in my work.
Yeah, I think just slowly, bit by bit, you get like indoctrinated into the culture of the communities and who are the important people and the kind of big themes that are going on. And I think that's something I had no idea about when I was an undergraduate. But if I could go back, I think that would have been a useful thing to be aware of. Oh, the other thing I would say is that, especially if you're trying to go for a machine learning PhD, then it would be often very helpful to try to develop both good coding skills and good math skills. A lot of PhD students come in with just one or the other. Like I just came in with good math skills. I have to essentially learn the other on the job, which is a kind of drag. Yeah. So if I could go back and do something differently, I guess I would have done a computer science undergraduate degree and done a lot of maths courses and become very good at, or as good as I can at, both maths and coding, like practical stuff.
So you would have done ComSci, because I'm doing some work on an idea for a product with a guy called Alex Matthews, who I'm sure I'm going to get on at some point, who's just started his undergraduate degree at Cambridge, and he came to me and mentioned that he was stuck because the university had said he could change from engineering to computer science, and he'd been working in Algomo during his gap year on one of our products called Tagomo, which is a data clustering tool. So he's a bit of a smart cookie. And I was like, well, I got no idea, mate. So Josh very kindly offered to speak to him and give him some advice on this decision. And he actually ended up choosing computer science. But I guess, Josh, could you run through what you said to him in those formative moments?
I mean, I don't think I necessarily, I think, I wouldn't give myself any credit for what he chose to do. He's a free individual and he made his own life choice. But I think like what I'd say about myself is totally different from the advice I give to someone else, because it really is. I mean, it sounds like boring and cliche, but it really is like a personal thing. Don't do computer science just because you think that that's like the right thing to do the next step. If you really love engineering, then you should go and do engineering, and then find a way to pivot that at some point into the next step. If you want to do some machine learning stuff, then you can find a way to do that. So I think that it really is a personal choice. And the reason why I say I would take computer science is because I actually quite like computer science. And so that would work out well for me. I would have been okay doing that, I think.
Okay. And I guess, not to completely run against your statement to say do what you want, but what are the compositions of undergraduate and master's degrees subject-wise in the researchers you surround yourself with? You can caveat this by saying, don't just do the one that's top, guys, but what is the one that's top?
Well, I mean, first things first, it is a computer science department. So I guess it's not surprising that probably the most common undergraduate degree was in computer science. But really people come from all over. There's plenty of people that did physics. There's quite a lot of neuroscience people, because of course, like there's a lot of philosophical overlap between like studying human intelligence, like the brain, and AI. And so there's actually quite a bit of interchange between those areas. Then of course, like there's maths, there's statistics. But really, like it's not so much like that. It's not so much what you study in your undergrad or the background you come from, but like the path that you choose to take, the interest that you follow, that really matter.
Okay, cool. Well, I guess we're coming towards the end there. I guess for a tail off note, maybe do you want to name your top 3 researchers that you follow on Twitter, that if someone wanted to take one takeaway, or 3 takeaways rather, that they would go on and follow right now?
Oh, who do I follow on
Start
Twitter?
with your supervisor, probably. No.
Oh, so I would start with my supervisor, except he has Twitter, but then he doesn't use it anymore. Like he like quit Twitter. I think it was bad for his health or something. There's a guy, Michael Bronstein at Imperial, who does a lot of graph representation learning stuff. He also works at Twitter. He does a lot of cool stuff, I think. And I follow him on Twitter. He's nice. Yeah, I don't know. There's just there's a lot of people. Yeah, I don't know. I'd struggle to give more examples, actually. There's another guy, Shakir Mohammed, actually, at DeepMind, who I think is cool and quite active on Twitter.
Amazing. Well, thanks for coming on, Josh. It's been a fantastic conversation.
Hey, anytime.
And yeah, I think I'll end it there. Cheers for coming on, and look forward to seeing you soon.
All right, brilliant. Have a great day, mate.
Bye.